Okay, so what we're going to talk about today is congruence and similarity in transformations. So far we've talked about 4 transformations. We did translations, just moving an image. Reflections, kind of flipping it. Rotations, rotating it. And then dilations, yesterday makes them bigger or smaller. So, to start off here, 2 figures are congruent. 2 figures are congruent if and only if there's a sequence of one or more rigid motions that maps one figure to another. And we kind of already addressed this on that very first day on Monday, because we talked about how rigid motion preserves angle measure and distance. We kind of mentioned on Monday, well, if it preserves angle measure and distance, it means that those figures are congruent. So because the composition of rigid motions goes from one figure to another congruent figure, they're also called congruence transformations. Congruence transformations. So if a transformation is a rigid motion transformation, meaning same angle measure, same size, it's a congruence transformation. So translations, is that a rigid motion transformation? Yes. Yeah, because you're just taking an image from here. Reflections, because you're just flipping it, right? Rotations, yeah. Dilations, no. Because dilations either make a figure bigger or smaller. So the first 3 are congruence transformations, but dilations are going to be compositions of rigid motions, and dilations are called similarity transformations. So produces figures that are the same shape, but not necessarily the same size, because they're going to be bigger or smaller. So 2 figures are similar if, and only if, there's a similarity transformation that maps one figure to the other. So some of the stuff we're doing today is what's called a composition of a function. This was 9.4, and since we're kind of down to limited time, I skipped 9.4 because I thought I could just kind of throw it in with this section. It's mainly more notation than anything. The idea is really simple. So a composition of transformations just means you're going to do 2 or more transformations to the same figure. So it might mean you're going to take this triangle, rotate it, and then translate it. Or maybe you take this rectangle and reflect it, and then rotate it. But you're going to do 2 or more transformations on the same figure. That's what a composition of transformations is. So for this one, it says in the diagram, okay, it tells me triangle JQV is congruent to triangle EWT. And we want to know, what is a congruence transformation that maps triangle JQV onto triangle EWT? So I'm trying to get from this one to this one. I'm telling you now that these are all going to be composition functions, okay? Which means we're going to need to do 2 or more. So I know sometimes you might just think, well, let me just rotate it. I promise you it's not going to be just rotated. We're going to have to do 2 or more, okay? Now, what I've kind of figured out through talking through second hour a little bit, I think the hard ones to try to decide between are whether you rotate something or whether you reflect something. So the first thing that we want to make note of is the congruence statement. So my congruence statement says JQV is congruent to EWT. And remember, that congruence statement is really important because it tells me what angles correspond with what angles. So whenever I map this triangle to this triangle, J and E should lay right on top of each other. Okay, so J and E. Okay, Q and W, and then T and V. And I think sometimes pointing those things out can kind of help you figure out whether you're going to do a reflection or a rotation. So, a rotation, okay, so what I want you to notice is that J and E are both at the top of the figure. We need them both at the top of the figure, right? So if I were to rotate one of these, that J's not going to be at the top of it. I see that? So I don't want to rotate it. Even if I rotate it twice, it's going to be at the bottom. I don't want to rotate it. But I also want you to notice that Q and W, see how Q's on the left and W's on the right? And then see here how V and T, but V's on the right and T's on the left? What do you think I need to do here? I kind of need to flip it around, right? So the first thing I need to do is I need to reflect it. Okay? So let's talk about the notation that we learned when we did reflections. So remember, the reflections was the capital R, and the subscript, kind of the rule, was the line of reflection. So if I'm going to reflect triangle JQV, what is my line of reflection to get it from here to here? The y-axis. Yeah. So your subscript is going to be the y-axis. Now we're not going to put the parentheses. I'll explain why here in just a second. But I think it might be helpful to actually go ahead and reflect it over. Reflections are usually pretty easy to do. So remember, for a reflection, to reflect Q, if I go 1 unit to get to my line of reflection, we're going to go 1 more unit. That would be my Q prime. J, I go 2 units. So we're going to keep going 2 more units for J prime. And then V, I have to go 3 units. So V prime, we're going to go 3 more units that way. So once I reflect it, it's going to look something like that. Now, reflecting it, remember, I need this figure to be lined up exactly with that figure, and right now it's just below it. It's oriented correctly, right? We have J, Q, V, E, W, T. See how the letters are in the correct order? I just need to move it. So if you were to describe how I would need to move this, what do you need to do? Go ahead, you.
Transformation of 0, 5.
Okay, so we need to move it up 5, right? So, okay, here's the notation that they talked about in 9.4 that we didn't do. If you are in Algebra 2 right now, you've probably seen this before. But there's this little tiny open circle. That means you're going to compose these functions. Okay, I'll explain more once we write it down. But it just means you're going to reflect, and then you are going to, now Leo said we need to translate. As a reminder how the notation for translation works, it's going to be those little arrows. And remember, for the translations, the rule's in X, Y. It tells you how you're going to move on your X-axis, so left and right, and how you're going to move on your Y-axis. Do I need to move this figure left or right? No. So it's going to be 0, how far up or down do I need to move it? 5. So 0, 5. That's going to be your transformation rule, okay? What the composition of functions means, and you'll get to experience this a lot next year in Algebra 2, it just means you're going to reflect across the y-axis. That image, you're then going to translate 0, 5. That's what the composition of function means. It means you're going to do this and then do that to this solution, okay? And one of the other things we're going to do today is we're going to actually do a composition of functions. So this says, and let's go ahead and let's sketch out this triangle. So triangle DEF has vertices D at 2, 0, E at 1, 4, and F at 4, 2. Okay, we're going to do 2 things. So if you look at the notation here, we have the D with the little subscript 1.5, and then the composition of, okay, the big R with the y-axis. So let's start with that capital D to the 1.5. What transformation does the capital D stand for? the dilation. What does 1.5 mean? It's 1.5 times larger than this one. So, I know I wasn't here yesterday to explain it, but dilations are really pretty simple. To dilate something 1.5 times, you're going to multiply the x and the y by 1.5. That's it. So let's first start by finding d prime. So to find d prime, we're going to take 2 times 1.5 and 0 times 1.5. 2 times 1.5 is 3. 0 times 1.5 is 0. We're going to do the same thing to find e prime, except we're going to take 1 and 4 both by 1.5. 1 times 1.5 is 1.5. 4 times 1.5 is 6. And then f prime. 4 times 1.5 is 6. 2 times 1.5 is 3. And let's go ahead and let's draw d prime, e prime, f prime. So we have d prime at 3, 0. E prime at 1.5, 6. And f prime at 6, 3. Now for the composition of functions, we did the dilation. We want to take the image of the dilation, and what does the capital R mean? Reflect. So we're going to take this image, my blue image, my d prime, e prime, f prime, and we are going to reflect it across the y-axis. So remember, for the reflection, you're going to take each point, go directly to the line of reflection, and then that same distance on the other side of the line of reflection. So if I start with d prime, remember, we're reflecting the image. We're not reflecting d, e, f. We're reflecting d prime, e prime, f prime. So for d prime, I would need to go 3 units to get to my line of reflection. So we're going to go 3 more units. And let's go ahead and let's call that d double prime. Because we already have a d prime, so just add another notch there and it would be d double prime. For e, I would need to go 1.5 units to get to my line of reflection. So we'll go 1.5 units again and get d double prime. And then for f prime, we go 6 to get to my line of reflection. So we'll go 6 more for f double prime. And there's the image of that composition. Okay, let's get this glued into, should be page 89, and this is 9.5 and 9.7, and it's congruence and similarity of transformation. All right, so I tried to include an example of everything you're going to be doing in your homework. I may have missed maybe a couple of things, but hopefully we can get the right idea. So you're going to have a couple of these. So for the coordinate grid, we want to first identify a pair of congruent figures. So out of these 3 figures, 2 of them are congruent, so you're kind of picking out the one that maybe doesn't match, would be another way to think about that. Then once we pick out the 2 congruent figures, we are going to write the congruence statement, and we will determine the congruence transformation that maps the free image to the congruent image. Okay, so first thing we need to do is we need to pick out of these 3 figures, which one doesn't fit. And they all kind of look the same, but there is one of them, the bottom one, yeah. And like I said, they all kind of look the same, but if you look at this bottom one, this point T, it seems to be maybe 1 point out too far. That one seems to be a little bit too far out there. So that bottom one is not the one that fits. So I think it's going to be helpful. I don't think it actually asked for a congruent statement, but I think it's going to be helpful, and you guys will see why. So if I were to write a congruent statement, let's start, for just consistency purposes when you guys get to your homework, let's start with the one that has the earlier letters of the alphabet. So let's do this polygon here, this quadrilateral here. So if we name it A, B, C, D, A, B, C, D is congruent to. So remember, the order of these letters is going to be really important. Okay? So A, looking at the second image, A corresponds with L. And you can see that it's kind of like that flat side there. A corresponds with L. And then if I go to B, it'd be M. And then you can kind of fill in the rest. L, M, and B. Just keep going around once you determine the direction. Okay, so we have our two congruent images. Now here's why, even though it didn't necessarily ask for a congruent statement, it asks you the congruent figure, so it'd be best to actually write a congruent statement accurately. Because remember, the congruent statement, like we just talked about, A and L are the corresponding angles. So when I do get these figures to lay right on top of one another, A and L should be in the same spot. And if I'm going to map A, B, C, D to this one, it means A, which is in the top of my first figure, needs to go to that left-hand side. So remember, I kind of mentioned this on the left-hand side, that if you notice with the reflection, like if I were to reflect it, the A would still be on the top. If I reflected across the x-axis, that A would come down to the bottom. I don't need the A on the bottom, I need it on the left. How could I get this figure, how could I move that figure, or transform that figure to get the coordinates in the right spots? I'm going to have to rotate it. See how, okay, if I need to do A, B, C, D, and then it's L and N, they all just need to kind of be moved, right? I just need to kind of rotate that image that way. So the first thing we're going to do is we are going to, that was wrong, rotate lowercase r. How much do I need to rotate it? Just 90 degrees, right? I just need to flip it once. If you were to go 180 degrees, that A would then go to the bottom. I don't need to, I just need to just flip it one spot. So we are going to rotate 90 degrees about the origin. I think it's probably going to be helpful to actually go ahead and graph that rotation, because when I rotate it, it's going to end up down here. I don't want it down here, I want it up here. So we're also going to have to do something else with it. So I think it's going to help to see that image. So a rotation of 90 degrees, if you remember from 2 days ago, that rule was negative y comma x. Was negative y comma x. So if A is at the point negative 2 comma 3, A prime, you're going to flip the sign of your y, so the 3 becomes negative 3, and then flip the x and the y, so it would be at negative 3, negative 2. So negative 3, negative 2. That's where my A prime is going to be. B prime. B is at the point 0, comma 2. So to rotate it, flip the sign of the y, and then flip the x and the y. So negative 2, comma 0. Negative 2, comma 0. Okay, C prime. C is at the point negative 2, comma 0. So flip the sign of the y, so the 0 stays 0. But then flip the x and the y, and it would be 0, comma negative 2. So down here. And then D prime. D is at the point negative 4, comma 2. The 2 becomes a negative 2, and flip those around, so it'd be negative 2, negative 4, negative 2, negative 4. So if you look at this now, I have my A, B, C, D, L, M, N, P. Okay, so it's all in the right order. So I don't want to reflect it. I don't want to rotate it again because it's going to mess up the order of the letters. I really just need to move it. What directions do I need to move it? Up and to the right. So the notation here, you're going to use that little circle. Moving a figure is what type of transformation? A translation. And then we're going to use those little arrows. Remember, for the translations, you have to do the horizontal movement first. So from my new image down here, what's my horizontal movement? And keep in mind that you need to line up A and L. So what's the horizontal movement to line up A and L? You need to go right 4. That will get me here. And then I need to go up 4. There's your composition, your composition of functions. Okay, this one's a little bit easier, but kind of along the same lines. So we want to find a congruence transformation that maps A, B, C, D to D, E, F. All right, so first of all, remember that the similarity, that congruent statement is really important. It means A is going to be mapped to D. Notice they're both at the bottom of the figure, which is a good start. But then I have B to E. One's on the right, one's on the left. And then I have C to F. Okay. So first problem, they're not oriented the right way. When I say that, I mean like it should be A, B, C, D, D, E, F. Okay, but they're not, because this goes bottom, top, right. This goes right, bottom, top, left. What's the first thing I need to do? I need to flip it. Okay, well, that's not really one of our transformations. What is flip it? It's a reflection. Okay, so the first thing we're going to do, remember the reflection is the capital R. What's my line of reflection going to be? It's going to be the y-axis. I need to reflect it right there. So we're going to reflect across the y-axis. And I think it definitely helps because that's not going to get me my image where it needs to be. C prime would be right there, B prime, and then A prime. So it really gets me pretty close. It almost is the right way. What else do I need to do? Move it down 2. So we need to translate. Remember, first is your horizontal movement. What's my horizontal movement? 0. Comma, what's my vertical movement? -2. Okay, so those are the congruence transformations. The next 2 are going to be the similarity transformations. So these are going to include one of the rigid motion transformations and then possibly a dilation. So for this one, we want to describe the composition of transformation that maps A, B, C, D to F, G, H. Now, what's the first obvious thing I'm going to have to do? Dilation. I'm going to have to make it smaller. I mean, right, that one's clearly larger than the other one. But you technically could do it in either order. I think it's easier to do the dilation last, and I'll show you why. So what we want to look at is notice that AB is the top, that top segment. FG, it's over here on the side. Okay, so if I want to map ABCD, I need that top to come over here to the left side. What one of my transformations could take this and move it over here? A rotation. Yeah, we need to rotate it just like we did on the last one. So the first thing we want to do is we want to rotate. How far do I need to rotate it? Yeah, just need to take it and just rotate it 90 degrees. I need that AB to come over on this side. So we're going to rotate 90 degrees about the origin. And like I said, I think it's going to help because with the dilations and everything, I think we're going to actually need to find A prime, B prime, and C prime. So remember, just like the last one, that rotation of 90 degrees, that rule is negative y comma x. So if A is at negative 2 comma 4, A prime, we flip the 4, become a negative 4, and then flip the x and y, so it'd be negative 4, negative 2. B is at the point 0, comma 4. So to rotate it 90 degrees, we'll flip the 4 to a negative 4, and then flip the x and y, so it'd be negative 4, comma 0. And then for C prime, C is at negative 4, negative 1. So we flip the sign of the y and become a positive 1. Flip the x and the y, 1 comma negative 4. And it'd probably be helpful to go ahead and graph that just so we can see it. So negative 4, negative 2, negative 4, 0, and 1 comma negative 4. Okay, so now it's doesn't look right because I grabbed something wrong. We'll move on anyway. Okay, so now I just need to make it smaller, which is going to be a dilation. So we know we want to dilate. The only thing you need to know with the dilation is the scale factor. Okay, so here's why I said I think we want to do the rotation first and then the dilation, because all you have to know is, so let's say I know G is supposed to correspond with B. So if B prime is at negative 4, 0, G is at the point negative 2, 0. I know to dilate something, I'm going to multiply the x and the y by the same thing. Well, how do you get from negative 4 to negative 2? Divide by 2. Multiply by 1/2. So my scale factor is 1/2. Okay, and then last thing, we have these two images, not in a coordinate plane, but we want to do a couple of things. So first thing, we want to decide if there is a similarity transformation, and if so, we're going to identify that similarity transformation and write a similarity statement. So first of all, I need to know if there is a similarity transformation, which means the indices would have to be similar figures. How are we going to know if two figures are similar or not? The sides are proportional. Now, if you look at it as it is, we're not going to be able to do 9 over 4 equals 6 over 6. That's not going to work. But, I mean, we're kind of thinking about the similarity. If I were to rotate it, and if I did maybe the long side, which is 9, over the long side here, which is 6, that would reduce down to 3 over 2. And then if I do the shorter sides, it would be 6 over 4, which also reduces down to 3 over 2. So it does look like there is a similarity transformation, but, I mean, first thing we said that it's not oriented the correct way. So what's one thing I'm going to need to do? I'm going to need to rotate it. And now for this one, we don't really have an origin, we don't really have a point, so we'll just write this out. So we'll say we're going to rotate it 90 degrees. So after I rotate this 90 degrees, what's another problem? It's too big. So I need to dilate it. Now be careful here, because if I'm going from the left figure to the right figure, it's getting smaller. It'd be 2 over 3. I have to flip that scale factor over. So dilate by a scale factor of 2/3. And then maybe not the quite obvious one, but if I just flip this and make it smaller, what else do I need to do? mine on those other ones, we had to like rotate it. I needed to lay right on top of it. I need to move it! And then I need to translate.